All right, hello once again. This is Jeff Scott from Rankin Technical College. I've been going over the PowerPoint presentations for Starting Out with Java Early Objects 5th edition by Tony Gaddis. We're up to Chapter 9. We're going to jump back into the topic of object-oriented programming with a chapter on inheritance. So we'll talk about exactly what inheritance is, calling the superclass constructor, overriding superclass methods, and note the word super in there because you'll see it again. Protected members, which we talked about earlier and we'll talk about again. Classes that inherit from subclasses, the object class, polymorphism, abstract classes and abstract methods, and interfaces. And what the author says here, and I don't want to go and read his words, but basically what he's saying is we live in a world where there is everything really revolves around objects, and basically every object that we work with is inherited from another object. And they give an example here. You could make a class that was called insect. And from insect, you could say, well, grasshoppers are insects, bumblebees are insects, etc. All insects share certain things. But, for example, grasshoppers can jump, bumblebees can sting. Grasshoppers, to my knowledge, can't sting, and to my knowledge, bumblebees can't jump. So as mentioned there in the bottom of the slide, grasshoppers and bumblebees are specialized version of an insect. So this is how you represent this pictorially. You've got the class on the top, which is the parent class, and underneath it, you've got the child classes, and the arrow, the colored in black arrow, basically means children of. So bumblebee and grasshopper are children of insect. So in the insect class, as mentioned there in the red, we can put in all the attributes that are shared by every type of insect, regardless of the type they are. Then in bumblebee, we can put those attributes and methods that are specific to a bee. In grasshopper, those attributes and methods that are specific to a grasshopper. All right. All right, sorry I had to pause for just a second. Again, when you talk inheritance, inheritance is made up of what are referred to as is-a or is-an relationships. So as it says, a grasshopper is a or an insect, a poodle is a dog, a car is a vehicle, an hourly employee is an employee, etc. So everything after the word a that you see in the examples there, in those three bullets, those are specialized objects. And a specialized object, as mentioned there, has all of the characteristics of the more general or parent object, plus any additional characteristics that you have that make it a specialized object. In object-oriented programming, you use inheritance to create an is-a relationship among classes. In Java, to create this, you use the keyword extends. As it says, using inheritance, you can extend the capabilities of a class. The general class is known typically as either the superclass, or sometimes it's known as the parent class. And the child class is typically known as the subclass, again, or child class. So the subclass, as it says, is basically extended from the superclass. Superclasses, again, sometimes they're called base classes. Subclasses are sometimes called derived classes. It doesn't really matter, all right? It's all wordsmithing, and it depends on the book that you read. So if you look at the bottom of this slide, they show you an example of inheritance. What they're saying in this case is final exam is a graded activity. So when you do this, the subclass, in this case final exam, inherits all of the fields and all the methods of the superclass without any of them having to be rewritten. And then it can add its own new fields and methods. So again, Java uses the keyword extends in the class header to define the subclass. So this subclass extends this parent class. So graded activity, as it says, contains all those general things for any kind of graded activity, not necessarily just a final exam. All right, it could be a quiz, it could be something else. It could be a homework assignment. It's anything that's graded. But a final exam, which is a child of that, has all of this stuff, plus it has the things that are unique to a final exam. Now, when the members of the parent class are marked as private, they're not directly inherited by the subclass. All right? They can only be accessed by the associated public methods. One of the reasons that you create all of your data members, typically, I shouldn't say all of them, but you typically create most, if not all of your data members as private, is so that you can use public get, set, and other methods to do the manipulation. Anything in the superclass that's marked as public is automatically inherited by the subclass and may be directly accessed from the subclass. Notice here, when an instance of the subclass is created, the non-private members are available, all right, non-private, through the subclass object. So if they're non-private, that means they're either public or they're protected. We've talked protected before. We'll look at it again in just a little bit. Non-private methods and fields of the superclass are available automatically to the subclass. Now, a constructor is not inherited. When a subclass is instantiated, so when you, in the example here, when you create a new final exam, that constructor, the first thing it does is it calls the constructor of the parent, which is graded activity. And that's what the author is saying here. And the super keyword refers to an object's superclass. Now, it gets to be a little dicey. It's a little different because it's probably not anything you've seen. As mentioned here, the superclass constructor can be explicitly called from the subclass using the keyword super. And there are examples in the chapter. All right. And you have to make sure if the superclass is overloaded, if the constructor for the superclass is overloaded, you must make sure you call the right constructor if the constructor's superclass is overloaded. Again, if you decide that you're going to call the superclass constructor from the child class, it must be the first Java statement. So the only thing that can be before it are either comments or blank lines. A subclass may have a method with the same signature as the superclass method. We talked earlier about overriding methods and what that stuff was about. All right, but more than that, because we didn't talk about it much, we talked about overloading methods. When you override, remember when we talked overloading, when the signatures had to be different, with what was in the parentheses? When you so we talked before about overloading. When you override like this, all right, the method signatures must be exactly the same. I gave you an example of this a long time ago, and it's not a great example, but it's the one I'll use. And I mentioned how if you get two parents who typically, that a man and a woman get married, and they both have a big nose. They have a child. There's probably a pretty good chance the child will have a big nose. All right? So they can either get a nose job or they can live with a big nose. They can't just take off their nose and put on another one. You can do things like that when you override methods from a superclass. If the method of your parent doesn't do what you want it to do, you can rewrite it in the child, but it has to have the same signature. So if you notice, we've got set score here that returns nothing and has a double passed in, and we're going to override it in curved activity. So, but again, it must have the same signature. So a double is passed in and nothing is returned. As it says here, this method is a more specialized version. All right? And it's very interesting when you start talking about the entire field of object-oriented programming, because quite often if you give, let's say, 3 developers the same thing to do, they may come up with 3 very different ways of doing it, and they may all be correct. And it's very hard to say, well, I would use this one because it's more correct. It's very hard to prove something like that. All right? We talked about the method signature. As it says, it's the name of the method and the data types that appear inside of the parentheses. So a subclass that overrides it must have the same signature. Everything must be the same. So if I decide I'm going to override this, let's say that we decided that we were going to override the get score. Wouldn't make much sense to do that, but let's just say we were. Down here, it would have to have no parameters, and it would have to return a double if we did it down here. Okay. If you want, you can always call the parent method by prefacing it with super. So if you override a superclass method, but then you decide later you want to call it, you can say super dot followed by the method name. And it's important, if you look in the second, third, and fourth bullets on here, you have to understand the difference between overloading a method and overriding a method. When you overload, all right, the method has the same name, but it must have a different signature. When you override, it must have the same signature. So, overloading, different signature. Overriding, same signature. And again, the only way that this will make sense is to start writing some programs that have this type of information in there. Otherwise, it's really and truly not going to probably make a whole boatload of sense until you start doing it. All right. Both overloading and overriding can take place in inheritance. They're not mutually exclusive of one another. You can do neither. You can do one, you can do the other, or you can do both. All right? But overriding can only take place in inheritance. So you can do overloading in non-inheritance situations, because we talked about overloading in past chapters before we got into the subject of inheritance. But if you're talking about overriding, that only can take place in an inheritance type of relationship. Now, if you decide that you don't want anyone to be able to inherit, and you don't want anybody to be able to change whatever method you've written, you can make the method final, as they show here. This is considered very poor programming practice. If you do this, as it says towards the bottom of the slide, if you say public final void message, then if a subclass attempts to override that method, the compiler will generate an error. This ensures that a particular superclass method is used by the subclasses rather than a modified version. The problem with that is sometimes you have to make a change to it. And by putting final, what you're saying is, well, you might have to, but I'm not going to let you. So how do you get around some of this stuff? Well, again, we've talked public, available anywhere in the class and to other classes. We've talked private, available directly only in the class. And remember, there's kind of an intermediate type of place that's protected. If I declare methods or data to be protected, they're available in the parent class where they're defined, and they're available in any child class, in any child of that child, and any child of that child, etc. So as mentioned here, a protected member's access is somewhere between private and public. In fact, I've heard different books refer to this, or seen it in different books. I've seen it referred to as semi-public or semi-private. As mentioned, sometimes using protected rather than private makes some tasks easier. But every time you make something protected, you're opening it up to be changed by more and more things. All right? So when you do that, you have to be careful that you know what you're doing. It's always very important as we look at this table that's from the book, or tables, that you sit down and you try to work out not only what's going to happen currently with what you're working on, but what might happen in the future with it. And that's always very hard because, I don't want to sound too trite, but no one can predict the future. So you might come up with a really good idea and a really good way of doing something that might make total sense in 2016, but come 2020, it may make no sense. All right, so they start to mention in here some of the differences, public and private. Public, again, everybody can touch it, everybody can do what they want. Protected, all right, accessible in the same package, and other classes in the same package, yes. Private, no. All right, the access modifier, available to other things outside, no for protected, no for private. The default one means that you don't say public, you don't say protected, you don't say private. If you say none of those, where it says default no modifier, that's also referred to as package access, which means that anything inside of that package will be able to access it, and outside of the package, it will not be able to. Now here we have an inheritance chain that's 4 levels deep. Again, since we're computer people, the first level will be level 0, then level 1, then level 2, then level 3. So a graded activity is a type of object. A pass-fail activity is a type of graded activity. A pass-fail exam is a type of pass-fail activity. So this is a child of this is a grandchild of this is a great-grandchild of this, etc. All right? And remember, object is basically at the top of the hierarchy, just the way that it's set up. So quite often when you start to create a picture of your classes, you do create what's called a class hierarchy to show the inheritance relationships between these. Years ago, I took a course in downtown Milwaukee, and it was interesting for a lot of reasons. It was taught by a gentleman from India who worked for Johnson Controls, who basically work with thermostats. And he mentioned how what they decided to do, they took 2 years at Johnson Controls to create a hierarchy like the one you see here. You see 2 years for that? No, theirs was about 500 levels deep. All right? And they wanted to make sure they didn't miss anything. Again, as I mentioned before, the object class is at the top of the hierarchy because all Java classes, directly or indirectly, all right, are derived from, or their parents are, object. Since object is in the java.lang package, you don't have to, there's no import statement. So here if we say public class, my class, this, right here. We wouldn't typically say this, but it's the same thing as saying it extends object. Now again, would you say that? No, I can't think of a time you would ever say that, but that's actually what happens. Because as mentioned on the bottom there, ultimately every class is derived from the object class. And what's in the object class? Not a whole heck of a lot. The toString method and the equals method. All right? And since they're in the object class, they're quite often going to be overridden in child classes. All right. Now, one of the hardest things for most people to catch on to is this idea of polymorphism. And I'm going to put another drawing in here that's going to be somewhat similar to the one I created before. and somewhat different too. So again, I'm going to hit enter a bunch of times. In fact, let me grab this. Oops. All right, hit enter a bunch of times here. Move that up, and let's paste it back in. All right, I'm going to change. I don't want this to be employee. I want this to be animal. And this will be dog. This will be cat. This will be bird. Oh, we'll put a couple more animals in there. This will be pig. Oops. So after bird, we'll put in pig. And after pig, we'll put in duck. That'll be enough. Okay, and I'll get rid of this full-time and part-time stuff here. All right, let me move this over so it looks a little nicer. Okay, if I decide in the animal class, I'm going to create a method in there, and that method is going to be called speak. So I'm going to create a method that's called speak. It won't have any body, it'll just have a name. Well, if I create this, first of all, you would probably never tell somebody, oh, I went out this weekend, I went to the pet store and I bought myself a new animal. Because that's way too generic. People would say, what kind of animal? Even to say I bought a dog is too generic because they're going to come in there and they're going to say, what kind of dog was it? Was it a Labrador? I don't know if that's even spelled right. Was it, I don't know, Maltese, etc.? Was it one of those? And you could keep listing them and listing them. All right? And I say I bought a cat. Well, what kind of cat did you buy? Did you buy a calico? I think that's what they're called, etc. All right? Then people would say, okay, what kind of bird did you buy? Did you buy a parrot or something else? You know, and I'm sure there's the same kind of things with pigs and with ducks. That's not what I'm trying to get across here, though. What I'm more concerned with here is this class would be so general in nature that I'd never create an animal object. All right? So that class would be referred to as an abstract class. Okay? And it's created solely so other classes can extend it. So dog extends animal, cat extends animal, bird extends animal, pig extends animal, duck extends animal. That kind of an idea. But if I define in my abstract class, if I define an abstract method named speak, that means that any class that extends, and let's not worry about these right now. That means that any class that extends animal must have a speak method. And what does that mean? Well, a dog, it's going to go woof or bark or whatever. Cat will go meow. Bird might go caw or whatever. Pig, oink. Duck, quack. All right? But the point is, all right, I'm not trying to impress you with my animal expertise, but what I'm trying to tell you here, and I think you all get this, is that each type of animal that we have here speaks differently. But if I go and I create a dog object, let's say I just do that. I don't even go any lower than that. I don't say that it's a Labrador or a Golden Retriever or a German Shepherd. We just create a dog. We call it Sparky. And we say Sparky.speak. It's going to do woof. We create a cat and we call it, Puff. Puff, puff. And we tell Puff, puff to speak. It's going to say meow, etc. So, in other words, the object, when it calls the speak method, it knows how to speak based on the type of object that's calling it. That is polymorphism. Polymorphism is actually a Greek term that stands for many forms. So what they say here, if you notice, a graded activity can be used to reference a final exam object. This is kind of confusing. But as mentioned toward the bottom of the slide, polymorphism means the ability to take many forms. In Java, a reference variable is polymorphic because it can reference objects of different types, different from its own, as long as those types are subclasses of its type. What? Well, we go back to what I talked about before, way earlier, right here, with these employees, I could make myself an employee array, and that employee array could hold hourly employees and commission employees and piecework employees. We're actually going to do something like that in a bit. All right, that's polymorphism in action. Now, there are a lot of good books that talk about polymorphism. There are a lot of things that are out there that talk about polymorphism that if you read them, you're probably going to get more confused than you would be otherwise. So I'm going to try to show you some stuff with polymorphism later in code. Polymorphism and dynamic binding. Remember, we talked about dynamic binding, also referred to as late binding. What that means is at runtime, you make the determination. We also talked about arrays in an earlier chapter and the fact that they're early binded, so it's at compile time when you need to know things. Again, it's the object's type rather than the reference type that determines which method is called, and there are examples in the book. I started to get into this idea of abstract classes with you, so let's take it a little bit further. So an abstract class, and before I showed you animal, an animal would be an abstract class. It looks just like any other class, but you use the word abstract between public and class. That means it cannot be instantiated, so that class name can never appear on the right-hand side of an equal sign. Rather, it's used as a template for other classes to be derived from it. So it's a superclass for other classes. The abstract class, as mentioned right here, represents a generic or abstract form of all the classes that are derived from it. Abstract classes can have both abstract methods and non-abstract methods. All right. If it has an abstract method, the method has only a header and a semicolon at the end. It has no actual body. All right. And they go through an example in the book here where they set up a student and a computer science student, etc. Again, in an abstract method, as shown in the example here, the keyword abstract appears in the header, and the header ends with a colon. There is no body to this method. What that means is any class that is derived from this class must have a set value method in it. That's exactly what it's saying. All right. One of the things that Java does is Java supports inheritance. That's what this chapter has been about. But Java only supports what's called single inheritance. What that means is that Java classes can have only one parent. There are other programming languages like C++ that support multiple inheritance, where a child object can have more than one parent, but not Java, not C# either. They're both single inheritance. So sometimes it's like, well, I need to be able to get other stuff in there than what I have. So you don't create another class to inherit from. Instead, you create an interface that you can do what's called implement. An interface looks similar to a class, but it uses the word interface instead of the word class. The methods that you put in your interface, again, have no bodies, only headers. So that looks a lot like what we saw earlier. So it's public interface and the name of the interface. That name has got to be what you save the Java file as, that interface name .java. All methods specified by an interface are public by default. A class can implement 0 interfaces. It can implement one interface, or it can implement more than one interface. Here is an example. So you can say that a class both extends another class and it implements an interface. And there's all sorts of different combinations of this stuff that you can use. An interface can have fields in it. All right, but any field that you put into an interface is automatically final, meaning it's a constant, and it's static, meaning that there's only one of them that gets shared by all instances. Since the data that goes in there is automatically final, you must initialize it. Again, there's an example of this on the bottom of the screen. My class implements 3 different interfaces. It implements interface 1 and interface 2 and interface 3. Interfaces in the unified modeling language are shown with a dash line, which basically shows that that's the interface. Okay. Polymorphism with interfaces here, as we're just about done with the chapter. As mentioned, Java allows you to create reference variables of an interface type. These can reference any object that implements that interface. It's another example of polymorphism in action, and they show that with a program that's in the book. I'm not going to run through that because, again, I don't have the book with me. And that's it for this chapter. All right, so we now have gone through the first 9 chapters, and next, I'll just save that, I don't think it'll hurt. Next, we will go through chapter 10, and chapter 10 is on exceptions and advanced file input-output. So I'll be back with that shortly.